Hello and welcome to my channel. So in today's video we are going to learn word problems on HCF and LCM. In the previous video we had already seen how to calculate HCF and LCM. While studying HCF and LCM, you all might have noticed that HCF is always a smaller number and LCM is always a greater number. For example, 6 and 9. We have taken this example several times, so we know that HCF of 6 and 9 is 3 and LCM of 6 and 9 is 18. So if you see here clearly, we can see that HCF is a smaller number compared to these two numbers given, and also LCM is bigger than these two numbers. So always remember that HCF will always going to be a number smaller than these two numbers and LCM is going to be greater than these two numbers. So if a word problem is given to us, according to the question, if you feel the answer is going to be a bigger number, then we calculate LCM, and if you feel that for the given question the answer is going to be smaller, then we'll find HCF. So going to the first problem, so let's read it first. In a school, there are two sections, namely A and B, of class 10. Section A has 42 students and section B has 48 students. Find the minimum number of books required for their class library so that they can be distributed equally among students of section A or section B. So here it is said that there are two sections of class 10, that is section A and section B. So in section A there are 42 students and in section B there are 48 students. So what we are told to find? Find the minimum number of books required for their class library. So we have to find the number of books for their class library so that they can be distributed equally among students of section A or section B. So in order to understand this question, I'll take a simpler example, that is 6 and 9. Suppose this is section A class and this is section B class. So in section A there are 6 students and in section B there are 9 students. So if you want books for the class library, in order to distribute those books in both the classes equally among the students, then the number of books must be a greater number. So that means we have to find a greater number, which is LCM, and we know that LCM of 6 and 9 is 18. So that means I need 18 books for the library. So when I go to section B class, now I have 18 books and I have to distribute them equally. So in class B, I will distribute 2 books for each student. That means 9 2s are 18. So that means I will distribute 2 books for each student. And in section A, I can distribute 3 books. That means 6 3s are 18. So in section A, I will distribute 3 books for each student, and in section B, 2 books for each student. So that means I should have minimum 18 books so that I can distribute them equally in both the sections of class 10. So this number, that is LCM, we have to find in this case. So this is just an example which I had given you all so that you all may be able to understand the problem. So I'll erase this part. So that means the number of books that I require to to distribute among these classes is going to be a bigger number. So that means I have to find LCM. So let's find. So we'll write minimum number of books required for class library is equal to LCM of 42 and 48. So now let's find the LCM of 42 and 48 by prime factorization method. So smallest prime number is 2, so 2 2s are 4, 2 1s are 2, 2 2s are 4, 2 4s are 8. So again by 2, 21 you keep as it is not divisible by 2. Then 2 1s are 2 and 2 2s are 4. Again 2, 21 you keep as it is, 2 6 are 12. So I'll continue here, 21 and 6. So keep 21 as it is, 2 3s are 6. Now both these numbers are divisible by 3, so 3 7s are 21 and 3 1s are 3. And now 7 1s are 7. So the LCM is going to be product of these factors. So 2 raised to 4 into 3 into 7. So this is going to be 2 raised to 4 is 2 cube is 8 and 8 to the 16 into 3 into 7. So this is going to be 3s are 18, carry 1, 3 1s are 3 and 4 into 7. So 7 8s are 56, 7 4s are 28, 29, 30, 31, 32, 33. So we found the answer. So 336 books are required for their library. So these are the least possible books that the class library should have in order to distribute them equally among sections of class 10. So moving on to the next question. An electronic device makes a beep after every 60 seconds. Another device makes a beep after every 62 seconds. They beeped at 12 am. At what time they will beep together at the earliest? So here we are told that there is an electronic device which starts to beep after every 60 seconds, and there is another device which beeps after every 62 seconds, and they both start at 12 am. So if they start to beep at 12 am, so the first electronic device will beep after 60 seconds, and the second device will beep at 62 seconds. So like this they will keep on beeping at different times. So we are told to find at what time they will beep together at the earliest. So we have to find the least possible time at which both these devices will beep together. That means the time we have to find will be greater than 60 and 62 seconds. So that means we have to find LCM of 60 and 62. So let's find LCM of 60 and 62 is equal to, so let's find the LCM using the prime factorization method. So 2 3s are 6, 0, 2 3s are 6, 2 1s are 2, again 2 1s are 2 and 15, 31, now 3 5s are 15, 31, 5 1s are 5, 31 you keep as it is, and now 31 is itself a prime number, so 31 1s are 31. So the LCM is going to be the product of these vectors. So 2 square into 3 into 5 into 31. So 4 3s are 12, 12 5s are 60. And then we have 31. So multiply 31 by 6. 6 1s are 6. 6 3s are 18. And this 0 you put it here. Since 60 and 62 are in seconds, so this will be also in seconds. So after 12 in another 1860 seconds, both the electronic devices will beep together. Now we'll convert these seconds into minutes. So to convert them into minutes, we'll divide 1860 by 60. So this will be minutes. You can simply do this by this method, that is, if 1 minute equals to 60 seconds, then how many minutes will be 1860 seconds. So if you say this is x and you cross multiply this, so this will be, this into this will be 1860 is equal to 60x. So I have cross multiplied, and then keep x as it is, and now 1860, this will be divided by 60. So like this you can find. Otherwise, if you all know, well and good. So cut this. 6 1s are 6, 6 3s are 18, and 6 1s are 6. So this will be 31 minutes. So therefore I can say that both the electronic devices will beep together at 12:31 am. Since they started at 12 am and now after 31 minutes they will beep together. So that means both the devices will beep together at 12:31 am. So this is the answer. So moving to the next problem. So let's read this question. Find the smallest number which when increased by 17 is exactly divisible by both 468 and 520. So we are told to find the smallest number which when increased by 17 is exactly divisible both by 468 and 520. So we have to find this number. So let this number be x. So we'll write let the required number be x. So we are told that when we increase this number, that which is x, by 17, that number is exactly divisible by both 468 and 520. So if a number is divisible by two numbers, it has to be a common multiple. So that means we have to find the least common multiple, which as per the question we are told to find the smallest number. So that means x plus 17, that is the smallest number when increased by 17, is divisible, that means LCM of 468 and 520. So this is what is given in the question. So the smallest number which when increased by 17 is divisible by both 468 and 520. That means it should be the least common multiple. Now we are told to find that smallest number. So what we have to actually find is x. So you can shift the 17 to the other side. So that means x is going to be LCM of 468 and 520 minus the 17. So that means in order to find x, first we'll find the LCM of 468 and 520, and then we'll subtract 17 from the LCM that we have found. So let's first find LCM of 468 and 520. So 2 2s are 4, 2 3s are 6, 2 4s are 8, 2 2s are 4, carry 1, 2 6 are 12, and 0. Again 2 1s are 2, 2 1s are 2, carry 1, 2 7s are 14, 2 1s are 2, 2 3s are 6, and 0. So again 2, keep 117 as it is, and 2 6 are 12, carry 1, 2 5s are 10. Now the next prime number is 3, so let's see if 117 is divisible by 3. 3 3s are 9 and 2, yes, so 3 9s are 27. Now 65 is not divisible by 3, so keep 65 as it is. I'll continue it here. So 39 and 65. So 3 1s are 3, 3 3s are 9 and 65. Now 65 is divisible by 5, so keep 13 as it is. 5 1s are 5 and 5 3s are 15. So 13 1s are 13 and 13 1s are 13. So LCM of 468 and 520 is 2 cube, 3 square into 5 into 13. So this is going to be 8, then 9 into 5 into 13. So 8 9s are 72 into 5 3s are 15, carry 1, 5 1s are 5 and 6. So we'll multiply 72 and 65. So this is going to be 5 2s are 10, 7 5s are 35, 36. So plus 6 2s are 12, carry 1, 7 6 are 42, 43. So 0, 8, 6 and 4. So here 4 6 8 0. So now we have only found the LCM of 468 and 520, that is 4680. Now we have to subtract 17 from this number. So therefore our x is 4680 minus 17. So if we subtract 17 from this number, we are going to get 3 here, then 6, 6 and 4. So this will be equal to 4663. So this is a number. So this is important. If we subtract 17 from this number, we are going to get the smallest number, which when increased by 17 is divisible by both 468 and 520. So in order to find the smallest number which when increased by 17 is divisible by both these numbers, we subtract that number from the LCM and then we get that number. So if we increase 4663 by 17, which is this number, so this number is then both divisible by 468 and 520. So that is this. So moving to the next question. So let's read. A packet contains Cadbury and Kit Kat chocolates. If there were 225 Kit Kat chocolates and 375 Cadbury chocolates, then find the greatest number of packets that can be made so that each packet has the same number of chocolates. So here there is a packet of chocolates in which there are 225 Kit Kat chocolates and 375 Cadbury chocolates. Now we are told to find the greatest number of packets that can be made so that each packet has the same number of chocolates. So that means now we are told to find the number of packets. So that means the number of packets of these chocolates will be greater or lesser than the total number of chocolates. So the number of packets will always be smaller number. So packets will be lesser than the number of chocolates in total. So that means we have to find, here we need to find HCF of 225 and 375. To understand this question, we'll take an example. Example of 6 and 9. Suppose there are 6 Kit Kat chocolates and 9 Cadbury chocolates. And now we have identified that our answer, that is the number of packets, is a smaller number. So that means we are finding HCF. We already know that HCF of 6 and 9 is 3. So now we are finding this number. So here we have to find HCF of these two numbers. Now what is told, that is find the number of packets that can be made so that each packet has the same number of chocolates. So now if we apply this to this question, so that means the number of packets is 3. So our number of packets is 3. So that means we have 3 packets. Now according to the question, each packet has the same number of chocolates. All these 3 packets must have same number of chocolates. So that means the total chocolates we have is 9 plus 16 is 15. So I can have 5 chocolates in this packet, 5 chocolates in this packet, and 5 chocolates in this packet. So I have 3 packets and each packet has the same number of chocolates, but we are only told to find the number of packets, that is HCF. So we'll find the number of packets if we have 225 Kit Kat chocolates and 375 Cadbury chocolates. So I'll erase the example. So let's find the HCF of 225 and 375 using the prime factorization method. So for that we separately prime factorize both these numbers. So now 225 is not divisible by 2, so we'll take the next prime number, that is 3. So 3 7s are 21, carry 1, 3 5s are 15. Again 3 2s are 6, carry 1, 3 5s are 15. Now 25 is not divisible by 3, so we take next prime number, that is 5. So 5 5s are 25 and 5 1s are 5. So here 3 1s are 3, 3 2s are 6, carry 1, 3 5s are 15. Now this number is not divisible by 3, so we take 5, 5 2s are 10, 5 5s are 25, 5 5s are 25, 5 1s are 5. So now we mark the common factors. So 3 is common, 5 is common, and 5 is common. So that means our HCF of 225 and 375 is 3 into 5 square. So these are common factors. So 3 into 5 square is 25. So 3 5s are 15. Carry 1. 3 2s are 6. And 7. So 75. So the greatest number of packets that can be made are 75. So therefore 75 packets can be made. So therefore 75 packets can be made with the same number of chocolates. So moving to the next question. So now try this question for yourself and tell me the answer in the comment section. So first identify whether the answer to the question is a bigger number or smaller number. And then if you think that the answer is going to be a bigger number, find LCM. And if the answer is going to be a smaller number, then find HCF. So in the next video, we will solve the exercise problems from NCERT textbook, that is exercise 1.1. So see you in the next video.